Hi, everyone, and welcome to this episode of Crowded Beaker Solves. Today, we're starting a new little series on isotopes. If you're watching this video, you are probably learning about isotopes and the fact that all the elements on the periodic table have different versions of themselves. They're not all the same. Like, for example, all atoms of iron are not the same, or all atoms of gold are not the same. One of the early scientists, John Dalton, said they were the same, and that's as good as he could do for the tools he had and the time he had. But later on, we found out that there are different versions of elements, and we call them isotopes. Okay, and what it causes those different versions? Well, for first, it's not the protons. So in any one of the elements, it's the number of protons that defines the element. So going back to iron, anything that has 26 protons is iron. That's what defines what it is. That said, not all atoms of iron have the same number of neutrons or even number of electrons. Electrons can be gained or lost. Neutrons can be picked up and maybe they just have them or have a shortage of them. And so the neutrons and electrons change. And so isotopes are versions of an element with different numbers of neutrons and therefore a different weight to them. A couple of quick terms that you'll need to know as we do isotopes is the atomic number, and that's that number in the upper corner of a periodic table usually, and that tells you how many protons. So if you're ever asked how many protons does something have, don't guess. Just go look at a periodic table. That's what it's there for. So that's that. There's also a term called the mass number, not to be confused with the atomic mass. See this number here, which is a decimal? That's actually a weighted average of a bunch of atomic masses or mass numbers. A mass number should be a whole number unless you're really technical about it. They do vary a little bit from whole numbers, but for our beginning purposes, they're going to be whole numbers. And so you'll need to know that. Okay, so let's look at a prompt. Let's get into trying to represent some isotopes. So I chose iron 56 as the prompt for this one. Now, when you're doing isotope notation, this video will be slightly longer because I'm kind of teaching you how to do it. So let's call it element X. You're going to have an element symbol. There is no element X, but we're just going to use that as our example. But then you're going to see two numbers to the left of it, and sometimes a number up and to the right. We'll get to those when they have charges. But the bottom number is going to be the atomic number, and that's going to go here in this little spot. And then the mass number is going to go in the top spot, right up there. So you'll see element symbol with two numbers to the left of it. Okay, so my prompt is iron 56. So in the name, I've already been given two pieces of information that I could just translate into this symbol. So let's first put the symbol for the element iron, which is Fe. It has nothing to do with the word iron, but that's because, hundreds of thousands of years ago, and still places today, they call it ferrum, not iron, and so Fe is the symbol we use. Now, in the name, this right here is the mass number. Not all atoms of iron have a mass of 56, but this one does. So we got to go with it. Some have 55, 54, and 57, and so on. But that's the mass number I'm using for my problem right now. And that's the number that's going to go on top. So 56 goes on the top. And then I need a number for the bottom. And this number, the one on the bottom, don't ever guess about it. You can simply go to your periodic table, find your element, and put that number 26 in the bottom. So let's get that out of the way. And that's 26. And that would be isotope notation for iron 56. Compare that to, say, iron 57. If I did iron 57, I would just keep the same symbol. They have the same symbol. They have the same number of protons, but a different number of neutrons. Now, that is not the number of neutrons. That's the protons plus neutrons in there. And if you ever needed to find out how many neutrons you'd have to subtract that. So we'd have 26 protons and 30 neutrons for 56, 26 protons and 31 neutrons for a total of 57. And just those are two isotopes of iron. All right, so remember this element symbol, mass number on the top, atomic number on the bottom. All right, moment of truth. Time for you to try. I've chosen another one of my favorite isotopes, strontium 90. So take a moment, grab your periodic table. You will need a periodic table to do isotope notation. Pause the video if you'd like and see if you can write a quick isotope notation for strontium 90. All right, so if you were able to write isotope notation and have it look something like this, then congratulations, you are off to a good start on isotope notation. Strontium is element 38 on the periodic table, so 38 protons goes in the bottom. 90 is the mass number, which is the total of protons and neutrons. And if you were to subtract those, you would find that it has 52 neutrons. So 38 protons, 52 neutrons for a total of 90. We haven't done anything with electrons yet. That'll be coming in a later video. But there you have it, a couple of isotope notations to get us off to a good start. If you have any questions or suggestions of isotopes, you can send me those. In the meantime, happy solving and have a great day.